Okay, so this is just going to be like a quick overview of what I've or like what we've been up to the past week. I've been like interfacing with Winston and Ari, and then I've been seeing you guys in the lab a lot too, and just asking you questions and stuff. And I'm trying to congregate everything together. And then for any members, like this is just kind of what's going on in terms of integrating the perception stack. So this is Project Guardian week 2, and this week was the theme was kind of like a deeper look into what we currently have on the cart, how to interface with those sensors, so that OPD LR camera and the LiveVox LiDAR, and then like what ROS2 pipelines do we actually need to like hook these up to our current system. So what did we do this week? It's kind of all summarized right here. So like uh, the intro that I gave last week, I kind of just recorded a video, so that's like on YouTube now, so you can send that to anybody if you guys need to. I think you guys already saw that in the Discord. And then this is the video where I sat down with uh, Ari, and he kind of like walked me through how to interface. You can see on the right here, that's us interfacing with the LiveVox LiDAR, and there was just some students sitting in like the DSE class. But he was showing like one of the teams in that class how to turn it on and like how to launch the launch file for the LiveVox. So we were just messing around with that. It's like a 25-minute video, and he just shows a bunch of really useful like commands. Code swimming, which is what I just call like just sitting and looking at all the code inside it's this GitHub repo. So it's like the AI racing tech race common repo. So just kind of going through that, studying, all the control and stuff. Mostly for me, I'm just looking at the perception stuff and like what's currently there. This stuff's a little confusing for me. I still have to study it. I don't know really what it is. And then so because I didn't know what it was, and I noticed that a lot of this architecture is written in C++, um, I studied ROS2 basics in like Python. So like I spent 3 weeks doing that, and then I saw everything was in C++. So I'm like, dang, I got to figure out, what's similar and what's different between the two. So that's like when I went in and I just did like the the construct ROS2 C++ basics in 5 days. And then I just did up to unit 3, which covered topics. So it's kind of giving me a better idea. And I'll show you guys at the end some similarities and differences so you're caught up if you don't already know this stuff. Okay, so interfacing with the camera and LiDAR, what did we learn? First off, this guy, Articulated Robotics, if you want to learn anything ROS2, he's like the man. I suggest doing the construct courses first and then going back and watching this guy's videos. And it's like he's just speaking, exactly what you need. And then one of the things we need is how do you interface with a camera on a robot? So he shows that like, hey, here's your camera. This driver node, this ROS2 node speaks that camera's language. So it'll pipe information in. And then through this node, it'll convert it into a readable format. And for cameras, that's image raw. So we're reading off of this like image raw topic. This is just if you want to do the 2D like camera feed itself. This is not the depth because I know you guys know that like OAK-D is equipped with like depth abilities and it's able to read like distances just from a 2D image, which is really cool. I'll talk about that in a second. But this is just the basic like, the camera feed. It goes into this topic called image raw. And then, you just pump it into whatever you want to do, algorithms and stuff, as he calls it. And then there's also one image raw compressed, but I don't think we're messing with that. And then if you want this video, I'll post these slides up in our drive too, so you can like go to this video. I try to put everything together that's useful. Next was interfacing with the depth camera. So in the video, you'll me and Ari and the DSC students, you'll see like he shows us how to get the depth feed up, and we did that by interfacing with this like point cloud 2 message. So instead of camera this time, instead of image raw, this is the type of message we're reading, which is point cloud 2, and you can see the pipeline down here. What comes out of the camera, it goes into like a these OAK-D cameras have like processing on board, which is really cool. You could do like all the obstacle detection before you even send it into the computer. And so he's just kind of showing here, like when you read a depth image, you'll get like white, which might mean like, oh, this is super close to me, or black, which means like this is really far, or vice versa. And you pipe that camera data into the depth processing. This goes into a depth image, which is this pixels you see here. This goes into a 3D projection and then point cloud. And then we visualized it using, I believe this was RViz or just one of the basic launch nodes. So that was pretty cool. This is just how you visualize the LiveVox LiDAR. So if you want a more detailed, overview, but it's the same thing as what we saw here. It's like you're just displaying this point cloud data, and this is what you see. This is his example, and then what I showed you guys earlier. This is, what we did here. So that was pretty cool. So that was, just that was awesome because I thought it would take us a lot longer to interface with those, but Ari showed us real quick, so that was awesome. And then yeah, the rest of the week I just spent studying the differences between the Python and C++ versions of ROS2, and I just want to show you guys like the highlights. So why would we even compare these? It's because Triton AI, I saw that they use primarily C++, ROS2 architecture. Many members learned ROS2 in Python because it's like the easier course to take. And then we have to understand the differences because it'll help us bridge the gap and improve like collaboration. So the goal here is just going to be like provide a structured comparison, highlight the differences in the structures, and then equip members if you guys don't already know what are the key differences. So first off, when you're messing with this stuff, you'll notice that like they share very common things. Like packages always contain launch files, and these launch files are always written in Python. So you'll see a mix even with the C++ architecture. The launch file is always written in Python. There's always a CMake list file. In the C++ version, you add your executables in the CMake list, whereas in Python, we have this special file called setup.py. And if you've gone through any of the construct tutorials, you'd know that this is where you add in like what they call entry points, or like when you launch a node, it knows exactly what script you're talking about. It's like where you glue them together. But they don't have that in the C++ version. You just do it directly here. And then you have package.xml, which includes all necessary dependencies. Same thing, Python, C++, they both have that. Differences, like I said, you add the executables in CMake list. Python, you do it in setup.py. This is just a little table that goes over some really important details. So node creation, like this is kind of a syntax comparison. I won't go through it all. You guys can kind of stare at it. The important ones are just node compare creation and publisher creation. So this is how you do it in C++ versus Python. I'll just give you a second to look at it, like just it's just different syntax. It's not much difference. And then callback attachment. Let's look at some actual code because this will give you a more clear representation. When you're declaring a publisher in Python, this is what it looks like. So you do self.publisher equals self.create publisher, and then you do what type of message you're going to use, the topic you want to interface with, and then the frequency at which you want to publish this message. And then subscriber, it's, what message you want to subscribe to, the topic you're subscribing to, and then this callback function you want to attach to this, like when you receive this data, what do you want to do with it? This is the callback function you attach, and then the security settings. Whereas in C++, this is really all we have. It's just declare a publisher, and you have this create publisher function. You specify what message. Here we did twist and stuff. What you're looking at on the left and right are basically the same thing. It's just different syntax. So that was the beauty of it. It is similar. It wasn't that much more for me to study. It's just different, arrangement. This is like an example of like if you have a laser scan message, so message or data that comes in from a LIDAR, this is what might be what, a callback looks like in Python. This is something you'll write if you go through the tutorial courses for the topics quiz. You'll write this laser scan callback function. So just kind of look at it, absorb it, keep it in your head for a second, because we're going to look now at the C++ version. So a little bit more verbose, a little bit more like everything's got to be by the book, put your parentheses, syntax needs to be perfect, but like the logic is exactly the same. So it doesn't seem like it's going to be that hard to understand the differences. Um, so what are the takeaways here? This is my final slide, which is when do we use C++ and ROS2? I mean, we're already using it on the car, but like just for your future knowledge, when you have performance critical applications like real-time control, low latency, this is why I believe TritonAI opted for a C++ build instead of Python, where it's maybe easier for people to understand. C++ is more memory efficient and has a like lower level integration. It works directly with embedded systems and hardware. There's no like conversions that need to be made. When you use Python and Rust 2, when you need to do like quick prototyping, that's kind of what Python's known for anyways. And then higher readability, it's easier for everyone to read Python, and then it's ideal for like data processing. But yeah, that's basically everything I did this week. And I just wanted to update you guys on what we're doing here. So it's everything from me. I hope I didn't go too long.